So, it seems that from a one-day visit you did learn a lot of things, and so I do wonder. It's of course just a snapshot in time of what you've been seeing. And for instance, you mentioned the avocado tree there, that it's just at one branch and it's really no big deal. Obviously, in Israel they have different perspective on that. And it may simply be a matter of time. And,
absolutely.
So it seems to me that we are in a really early phase here, and trees not dying immediately is obvious. It's early in the infestation, and I think in your remark about getting rid of the trees that do produce offspring, in let's say in the greater LA area, they like to breed in Quercus agrifolia that is planted along many a street, and so getting rid of those trees, and it's a native tree, also maybe just beyond possibilities in the short term. So I think we do have, like you say, a major problem, and I don't think that we can simply solve things by removing the host.
So I perfectly agree with the beginning of your statement, absolutely 100%. We are at the early stages, and if we want to prevent an outbreak like the one we see in Israel, we need to do something. I agree with that. Maybe I misspoke about removal of hosts that produce beetles. I did not mean the whole species removal. What I meant was that if you remove 90% of the trees that are now trees individuals that are now producing the beetles, you would knock down the population significantly, and it may help. Yeah. And so I'm not proposing, clearing the streets of trees. What I'm proposing is to let people know that we have a problem, let homeowners, garden owners, nursery owners know that if they see something like that, it needs to be disposed of right now. Yeah. And not the whole species, but the actual trees that are teeming with beetles.
I agree. And the unfortunate thing is, like, we've been talking to the nursery industry, and the nursery... Oh, thank you. See, is this thing on? Should be on. Okay, so the nursery industry, I'm sure they want to stop this thing from spreading, but we don't have anything to tell them what they can do to their living trees. Okay, you got a living tree, it's infested. I'm a nursery man, I want to sell the bloody thing, and I can only sell it if it's free of this beetle. What am I going to be doing? And we cannot tell them, you just dump this stuff on this plant, and the beetle dies, and you can sell this healthy tree. So it's, I think a bit of a problem that we have at the moment is that we're indeed so early on in the infestation, and we can come up with wonderful, let's say theoretical solutions. Unfortunately, the reality of the situation is such that, first of all, there's a huge area already infested, and at this point we don't have anything to offer somebody who's got an infested tree, except for saying, get the thing, kill the tree, and then we don't even know how to dispose of the wood properly. So it's a problem.
It's a matter of research that needs to be done right now.
Yeah, Jiri, just to me, one of the complicating factors here is, again, this complication that there might be cryptic speciation within the beetle and the fungus. But that said, it seems to me now that this thing is being seen in a lot of different environments. I'm from Florida. We've got people from Australia here. We've got people from Israel and California here. There's an opportunity here, I think, to understand what these various factors are that do result in major damage. What distinguishes Israel and California from Florida, for instance? Understanding that then might, in various locations, and we could address whether overwatering or these other factors play a role if we understand in a geographical sense what's going on in these different countries. So, nice talk.
If I may, just a quick comment on that. I absolutely agree. I think it's not a matter of an insect and fungus. It's a matter of an insect and fungus and the landscape and hosts. And yes, as a sort of more of a theoretical hunt for questions, this is the first one that I agree should be solved to be even able to predict where else it's going to go next. But the sad case is that I think we should get on it locally and figure out what to do with those damn attacked trees. Yeah.
Jiri, just wondering, I guess the obvious biological question is about inbreeding depression of the species, and also I was just thinking you could imagine in a wild ecosystem where you had like a population of clones and more than one clone could colonize a tree. Is there any chance of sort of crossover between brood galleries of males?
Right, very good question. It has been studied a little bit. There are very few papers on it, but they exist. And we see that even though the vast majority of the families never interbreed with any other family, the males always stay in their gallery and just die there after mating with their sisters, there are occasional males that come out and crawl on their tree. They are flightless. They're like wimpy males. They really don't have wings or anything. They crawl on the tree, and if they find other gallery, they try to get in and mate with other sisters. So there is an occasional outcrossing in those normally inbred populations that is responsible for a little bit of a gene flow. It's nothing compared to irregular outcrossing populations, but there's a little bit of that. So they're not entirely clonal. They're just mostly clonal. And I'm hoping that answers your question.
It does.
Okay.
Jiri, oh, thank you. Very nice talk. Thank you. I enjoyed it a lot. I would like your thoughts. I know this will be pure speculation, but given what you know on ambrosia beetles and these other invasives, the 13 that have moved globally and caused big problems, based on what you know about those systems and this, do you have a feeling for how this beetle may have come to California? Do you think it was moved on live plants through the nursery trade, something like that, through packing pallets? And based on what you know about the phylobiogeography of these things, do you have an inkling as to perhaps what parts of the world this beetle may have originated from, and whether there were trade pathways that could have facilitated that movement?
Yeah, excellent question again. Fortunately, there has been research on that already, at least theoretical research, quantifying the methods or the pathways how these nasty invasives get around the globe. And in terms of wood-boring beetles, it's very often wood pallets, for example, packing material, solid wood packing material, untreated wood that just gets shipped without any control around the globe. And if you ever have a chance to witness what happens when a giant container ship arrives to an LA port or somewhere, and when they open up those containers, look at what's coming out. There are so many insects that I'm surprised that we don't have many more problems. It's pretty disturbing. I also hear, I'm not sure if that's confirmed, but I also hear that the ports of entry facilities have only enough manpower to check about 2% of cargo, which is nothing. It's not even monitoring. So wood is a major problem. Live plants, soil, another major problem. These things can survive for a long time in wood. So my gut feeling would be that wood is most likely to be the culprit here. But any number of other ways how these things could get around. The problem is that there are regulations for treating wood, treating packing material before export and import into other countries or continents. But they require investments, and not everybody does that. And that's a problem, mostly from the tropics, where most of these beetles are, and where the countries usually don't have money. They just don't do that, and that is a problem. So I have no clue where this species came from. I think Richard will give you a better answer, because I believe you guys are working on a population structure, global population structure of the species. So I don't know. I don't have any data to say, but so I don't know.
So just what you've suggested, that these beetles could possibly live in dry wood pallets. That's
I wouldn't say they
possible?
would be happy there, but they can survive there, that's for sure. So if you have a teak tree somewhere in India and you make pallets out of it, when it's still fresh, the beetles will attack it. That happens all the time. They drill holes in it, and they make galleries and they survive there if it's moist enough. And if you are quick enough to use that pallet and bring it over to the United States, they will come out. Absolutely.
I would say on the pallets, it's less likely that they attack the pallets, rather that looking at some of those branches at the sites we looked at yesterday, I could easily conceive of cutting something like that up, cutting into pallets, nailing them, and it's the survival of those that are being carried along. So I think one of the things, and you referred to this on the trade and a number of containers, is just because you have an unlikely event, a low probability event, if you do it often enough. So it just takes one. So I mean, I don't think they're attacking the newly cut wood. That seems pretty unlikely, but certainly that they'd be in the wood that's cut up. So I think that's highly likely.
That is an
a very
excellent
good
point,
source.
that it only takes one. In case of these clonal inbred beetles, only one specimen is enough to establish a whole population, unlike in many other organisms which need a male and a female to mate. These guys don't. And so that's why, even though these beetles form about 2% of the global diversity of pests, they form about 50% of all invasive pests, because they're really good at invading.
Is there any idea of what food source is better, which fungi that is found on the different parts of the ambrosia beetle support that population better, and are those fungi better adapted to certain trees?
My observation is that, it's not hard data, it's my observation is that the fungus that is likely the best, most nutritious for them is the one that has co-evolved with them, and that has really co-evolved with their mycangium. There is some chemical communication going on in the mycangium between the beetle and the fungus. We don't know anything about that. But the beetle somehow makes sure, or maybe it's the fungus itself that makes sure that that one most nutritious fungus dominates in the mycangium. That said, we know that if you take a beetle out of a gallery and put it in another gallery that was artificially inoculated with a different fungus, the beetles do okay. So they are not entirely fungus specific. They're also slightly polyphagous in the terms of the fungus. And I always like to say that they're kind of like people. We don't just eat wheat or just rice. We have a certain number of plant species that we mostly eat, but we can really happily switch between them. So it's like the beetles. They have mostly one fungus at a certain locality, but they can swap it, and on the other side of the planet, they might as well have a different fungus, as long as it fulfills the feeding function.
I have some preliminary data on that, what we found on what part of the beetle and larvae, so I'm going to talk about it this afternoon.
Perfect.
So Jiri, I just had a quick question for you.
Oh.
So do you think that the feature of ambrosia beetles carrying virulent pathogens is a more sort of evolutionarily advanced feature? I mean, most of them don't carry. I mean, they're normally going to trees that are already dead and dying. So why would they carry pathogens with them if their normal sort of biology is that they don't need to kill the hosts? The hosts are already on their way out.
It's about the most complicated question you could have possibly asked. So very shortly, I will say that there's really, as far as you know, only one case where an ambrosia beetle carries a really virulent pathogen, which is the red bay ambrosia beetle in the east. All the other cases are cases where, or most of them are, where you need many inoculations, many beetles to overcome a healthy tree. So they really don't, I wouldn't say that they carry virulent pathogens. That happens, but it's rare. What they often carry is fungi that are weakly pathogenic, because that's helpful. If your normal habit is to attack freshly dead trees, it's helpful to have a weak pathogen with you. Or I should say, for the fungus, it's helpful to be weakly pathogenic, because they're better at conquering the surrounding wood or phloem or whatever you're up to conquering. And so they do have some capacity to overcome localized tree wood defenses. And so when you then get into an area where these trees have not been exposed to those fungi, those weak pathogens become little stronger pathogens. And if there are a lot of them, we as people tend to see the end result. But the fungus, I wouldn't call the fungi virulent pathogens. That's rare.
Do we know much about the flight activity of these female beetles? Are they aggressive flyers, or do you see a spectrum from those that just crawl up the trunk to maybe species that can fly, many kilometers?
Oh, so you're asking about the time of a day or how far they can disperse?
Dispersal capacity.
Somebody may have studied that. If yes, let me know. What the little I know is about the curve. Here's a tree, and this is 10 kilometers of a distance. Large majority of the beetles will end up as close to the tree as possible. There are some that don't find anything, and they just keep flying until they find something. And so it's like a trailing end. So there is really no end limit that we know. They will just keep flying until they find something. And we know from, for example, Ips typographus, which is a European spruce beetle, they were found 60 kilometers away from the nearest attacked spruce. It's super rare, but it happens. But the vast majority of beetles, they don't have any interest in flying far away. They just have an interest to find a tree as fast as possible.